2010 A3. So a parabolic curve is often used in the design of racing tracks. The drawing on the right shows the axis, directrix and focus of a parabola. Locate the vertex and draw a portion of the curve. Now you'll notice on this one we haven't been told what the eccentricity of the curve is, like we're usually told with other questions similar to this. The reason we haven't been told is because the eccentricity of a parabola is always 1. In other words, our line of eccentricity is always 45 degrees. The reason being, if I measure out 1 and measure up 1, we will get a point there. It will give us a 45 degree angle. So there is our line of eccentricity, so 45 degrees. Next thing then, locate the vertex. So from point F, 45 degrees, line to the line of eccentricity and then straight down. And we label that V. Next step then, from point F, I'm going to draw in my latus rectum, which is a vertical line perpendicular to the axis. And straight away, where the latus rectum hits the line of eccentricity, that gives us a point on our parabola straight away. I'm going to put in some ordinates now. So I'd always begin by picking one there between V and F. And then I'm going to go off over to the right there. I'll put in maybe 4. 4 over to the right, and then I've 1 there between V and F. Up to where they hit the line of eccentricity. Where they hit the line of eccentricity then, they'll be going across or parallel to the axis until they hit the latus rectum, which I've highlighted there in pink. Like so. Next thing then, compass, which always goes on, our focus. And I'll set it up to the top there, the highest horizontal line. And I'm going to swing an arc down there. And I'm also going to swing it off there at the bottom. Save me coming back to axial symmetry, I'll do it now. And I'm just taking that point as well where the latus rectum intersects the line of eccentricity. And then swinging it down underneath. And then lastly then my point between V and F. And then I'm going to draw in my parabola. And there is a portion of the curve. Part B, draw a tangent to the curve at a point 45 millimeters from the focus. So what you need to do is set your compass to 45 millimeters and swing an arc from point F. Okay, so set your compass, point of it on F, swing an arc there which touches the curve, or intersects the curve. I'm going to call that point P. Now, the easiest way to draw a tangent is to join P to F, step 1, like so. Go 90 degrees to that line. From F to where it hits or intersects the directrix. So that's 90 degrees there. And where this intersects the directrix, we join it to P. And that is our tangent.